All right, good morning once again, everyone. Welcome back to another class. So, today we're going to be starting chapter 7.3. Tuesday, we would have finished off 7.2 with covering all of these features within the past few classes. So, today we're going to be looking at how do we develop a spreadsheet. What goes into developing a spreadsheet? And we're going to be looking more at functions. What are the other functions that basically would be useful to you to use in spreadsheets? And we'll also look at relative and absolute addressing, what they are. Anybody remember when I was copying a formula, the formula was changing? Anybody remember that? No one? Alright, so when you copy a formula actually changes based on its location, and it has to do with its topic of relative and absolute addressing. So when we get to that topic, we'll understand why formulas change when we copy them. So to get us started with our planning of our spreadsheet, what goes into developing our spreadsheet, the first two paragraphs we'd like to have, let's see, Kezia, can you start the reading for us?
Yes, sir. As with other computer applications, the best results come from thinking about the task in hand. When planning a worksheet, ask yourself the following four questions. What is the goal of the worksheet? What are the desired results, outputs? What data is needed to calculate the results, inputs? What calculations are needed to produce the desired results?
Continue.
Sometimes a spreadsheet is created to solve a problem for just one user and is never used again. It is set up quickly to get some result, but the appearance is not important. No one other than the creator of the worksheet will see it since it will only be used once. The creator of such a spreadsheet would still consider the four questions above, just not in a structured way.
Great. Have any of you ever used spreadsheets to do any assignment or to do any work?
No, sir.
No, sir.
No,
Yes,
sir.
sir.
Yes, I heard a yes.
I did use Excel last time for a PE assignment. This a PE assignment.
Uh-huh.
After putting do this, I'm recording every 3 weeks. A weekly record. Put on what you do weekly.
Mm-hmm.
Of the push-ups and see how you're improving over time. Yeah, that's what I had to do.
Good, good. So when you when you were creating that spreadsheet, did you think of how to put in the information, like to design it nice, or did you just type it randomly?
No, I didn't have to use stuff like calculating. Just got put it in and different put in numbers, and every week I have to change them. I put in a different every few weeks.
Good. But what I'm asking is that, say for example, when you were putting in your information, did you type it randomly all over the place? Or did you think of like an organized way of typing in the information?
I put in an organized way and unorganized way.
Right. So you create like a table and you put in the information.
Yes, sir.
Right. So that example there that Emmanuel does give relates to what we are looking at this morning. Oh, another question, Emmanuel. Have you used that assignment back since?
No, sir.
No, you haven't. So that relates to the first part of our planning for a spreadsheet. When you're planning for a spreadsheet, you would usually ask these questions here. What is the goal of the spreadsheet? What am I creating it for? So in Emmanuel's case, he was creating it for an assignment to record data. You have to think about what are the results? What do I want to see in this spreadsheet? What data, question number 3, what data am I going to put in? How many push-ups? How long did I take, and so on? And if there's any calculations to get the result, what kind of calculations do I need? So when you're making a spreadsheet, so basically record data, you would think of these questions. Now, in some cases, like Emmanuel's case, you may only use a spreadsheet once. So you only have to use it one time because somebody gave you an assignment, or you want to do some recording of some sort of data to see the results. So you only use it one time. So the order of the questions might not be in a structured way. You might not answer the questions one after each other because just for your personal use. So it doesn't really matter how you go about answering the question once it's for your personal use. So how you put in the data, the appearance, it would not be important because it's for just your personal use. Joshua, you're unmuted. So, but when it comes now for actually designing a spreadsheet, say for instance, your parents has a business and they ask you, look, I hear you're doing IT in school, could you help me make a spreadsheet? Or your uncle come over there and say the same thing. Or you see some sort of part-time job and they require you to have this skill. How would you go about designing a spreadsheet now for a more professional use case? Well, Monique, could you read the next 2 paragraphs for us so that we can get that information?
Sir, another form of worksheet is one that will be used many times, but only its creator will be using it. So the author will take a little more time with the above questions, and the layout and appearance of the spreadsheet will probably be better. The final category of spreadsheet is one set up for someone else. More time must be taken to answer the above questions, and the spreadsheet will need good design and good documentation. Since other people will have access to this spreadsheet, the creator of the worksheet may have to meet with these users many times so that they can make suggestions and approve it until it is finalized.
Good. So we have different situations here of when and who will be using your spreadsheet. So the first situation was a temporary situation. You just need it maybe for a one-time assignment or a one-time recording of data. So design and appearance does not matter. You might be thinking of these questions. You will be thinking about these questions, but just that it won't be in a structured way. You will think of how to design the table and how am I going to put it so that I can see it nicely. So, but it's not really that important. But if you're going to use the spreadsheet more, more than often, maybe on a regular basis, every month or every week, you're going to be using the spreadsheet, then you're going to be thinking about the layout. So you're going to be thinking about the appearance. How am I going to design the spreadsheet? How am I going to make it so that it is something presentable when I am using it often? For example, like myself, I use Spreadsheet so that I can record grades. So, for example, let me see, when you guys were in third form, I was keeping a mark book looking like this here. So this case here, I would have had to think about how am I going to design this spreadsheet so that the data is organized, it has a neat layout so that I can neatly put in my information, so that I can put in new information that might appear. That deals with planning. So if you're gonna constantly be using a spreadsheet, you need to think of how can I put it in such a way that it can be used further in the future. Now we have another situation whereby someone may ask you to design a spreadsheet for them. So your parents might ask you, a family member might ask you, or say you have a job and they ask you to design a spreadsheet so that they can record data, do some calculations. I'm going to give the example of an invoice. Say for instance, your parents own a business, or you got employed by a business, maybe a supermarket, and they ask you to design a spreadsheet so that when you put in the items, it's going to calculate the price, it's going to calculate the VAT, it's going to calculate the total, all of the necessary information it's going to calculate. Now that's going to be used often. So you need to think about these questions here. What is the purpose of that spreadsheet? To calculate prices, to calculate VAT, to show the information in such a way that it is easily readable, that persons won't be confused. What are the results? I need to see total, I need to see VAT, I need to see the discount. What data do I need to put in? The item name, the item price, the VAT percentage, the discount percentage, and what calculations do I need to get those results. So in this case, you're going to have to be thinking in a more structured way when you're going to be designing a spreadsheet for a more permanent use. And especially when you're designing it for someone else, you need to design it in such a way that when they look at it, they basically should understand how it is structured. For example, well, when I was designing this spreadsheet, it wasn't designed for anybody else to use, but looking at it, do you guys understand the structure of it?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, you can somewhat understand it, that this column here is for last name, this column is for first name. Well, CW would represent coursework 1 because, as I mentioned, it wasn't designed for anyone else. I would understand that CW means coursework 1. The number below represents was the total for that coursework, and these represent the grades that students received for that coursework. This would be the coursework total, this would be their grade, their percentage, and so on. So in my situation, for my personal use, I understood it, and I could have continuously used it for any future use case. But if I were to give you this spreadsheet here, if some of you saw CW, you might not have known what CW meant. If some of you saw these values at the bottom, you might not know what they mean. So in that situation now, if you're going to design a spreadsheet for somebody else, you're going to need to think of how can I design it in such a way that when this person opens this spreadsheet, they can be able to understand what is inside of it. They should know just by looking at it that this column refers to coursework 1, this one refers to coursework 2, and so on. They should know how to put in the information, how to put in the data, there shouldn't be any confusion because you are making it for them. So in that case, you're going to need to think of the questions more thoroughly so that you're going to design it in such a way that they understand. But not in all cases you might be able to accomplish that. Not in all cases you might be able to design it in such a way that any person might be able to fully understand it. That is where good documentation comes into play. So you can create some documentation whereby in a spreadsheet we have what is called comments. Just like in Microsoft Word, if we go to review and we go to new comment, we can actually add a comment to a cell. So in this comment here, we can say maybe this is course work 1. So that way now, whenever this person wants to know what this information here is referring to, they can hover over it, they can click on it, and they will see the comment. That will be good documentation. They're going to know that what it represents so that they know what they're working with. This 36 here, they might not even know what this 36 represent. So they could put in a comment, this is half of the total grade, thus pass grade. Something like that, so that they understand what it represents. So that there would be good documentation. You don't have to document inside because basically we're going to start ending up with a lot of comments all over the place, and comments can be kind of annoying. So you can actually, in that case, you create a separate document and you document how different features and different cells would be used and so on. So when it comes to designing a spreadsheet, you ask yourself these questions here. If it's only for personal use, a one-time use, then the questions aren't that important. But if you're going to be designing it for yourself and it's going to be used regularly, then you're going to need to think about the questions, more so if you're designing it for somebody else. You will definitely need to think of the questions so that you and the person will be able to understand how to design the spreadsheet. Are you guys following?
Yes,
Yes,
sir.
sir.
Yes, sir.
Any questions?
No, sir.
No, sir.
Alright, so that is how basically the steps for designing a spreadsheet. Now let's go on to look at arithmetic formulae, and let's see, and we're going to have Morano. Can you read for us?
Alright, good. Arithmetic formula. If you have many operators in a formula, it is important to follow the rules of the formula. Help me, sir. Sir, can someone else pick up the name, please?
Okay. Fulan, can you help him out?
Arithmetic formulae. If you have many operators in a formula, it is important to follow the rules for the order of operators. You probably have come across a mnemonic BODMAS in maths. The first letter of each word stands for the operator. B for brackets or parentheses, take precedence over any other operator. The computer must calculate the part of the formula in brackets first. Order means raised to the power of number, such as 2 to the power of 2. Division and multiplication are calculated next in the order left to right as they appear in the formula. Addition and subtraction are the last two operations to be carried out. Again, these are calculated in order as they appear from left to right in the formula. In a spreadsheet, formulae are used to calculate answers based on the mathematical equations that you create. When creating formulae, you must use actual values, cell addresses, a combination of two. To continue, sir?
Yeah.
To enter a formula, you must 1. Click the cell where you want to insert the formula. 2. Press the equal sign. 3. Enter the formula. 4. Press enter.
Great, thank you. All right, so firstly, I want you guys to take note that when it comes to IT, quite a few of the skills that you would learn in other subjects, you might apply them in IT. So for example, I'm sure all of you know what BODMAS is. Is that correct?
Yes, sir.
Yes, sir.
Is there anyone here that doesn't know what is BODMAS? So that we can send them back to primary school. Right, so all of you should know what BODMAS is. Now, when you're creating your formula, it follows the rule of BODMAS because, as I mentioned already, you're basically creating an equation to do a calculation, and it's using the same operators. It's using division, it's using multiplication, addition, and subtraction. In some cases, it even uses brackets because just like in a normal equation in maths, when you want some sort of calculation to be calculated first, some sort of part of the equation to be calculated first, you put them in a bracket. So it's the same for your formula. If you want a certain part of your formula to be calculated first, then you put that in a bracket. So for example, when we're creating a formula, we might do equal 8 plus 6 divided by 3. Or let's do 3 plus 6 divided by 3. What is the answer here?
3?
3, sir.
That is correct. 3 is correct. Because you have to do division first. So 6 divided by 3 is going to give us 2. And no. 3 divided by 3. Yeah, that's 2. And plus 3, so isn't that supposed to be 5? What am I calculating?
Sure, you have to do the first part.
Yeah.
You have to bracket out the 3 and the 6, and then after you get your answer, you have to divide it by the 3.
Yes, sir.
I was looking at this thing this morning. I don't know why it's confusing me now.
Sometimes it just happens, man.
No, I think... No, the answer is 5. The answer is 5. Because I just confused my whole brain. The answer is 5, because 6 divided by 3 is 2, and 2 plus 3 is 5. Yeah, I'll check it on your calculator and then confirm it, because it is 5. Either way, so in this case here, say for instance you wanted to do the addition first. So just like in normal maths, you'd put your bracket. So if you put your bracket here, then the bracket has to go first. So if you try this now, then your answers should be different. Then that's going to be 3 plus 6, and that's going to be 9 divided by 3, which is going to be equal to 3 now. So just like in maths, when you want a certain part of the equation to be calculated first, you use brackets. Same with your formula. Just like how I added these brackets here, it is going to work the same. So if I should have done it in spreadsheet so that you will not have had that confusion. So let's try it in spreadsheet now. So equal 3 plus 6 divided by 3, answer is 5. So now if I put brackets, so I'm going to put a bracket around 3 plus 6, notice the answer change. It is following that rule of BODMAS. So some of the skills that you will learn in other areas, in other languages, other subjects, you will apply it in IT. For example, later on, when we are going to look at word processing in the final term for fourth form, in English, you guys would have learned how to design a letter. You would have learned about the layout of a letter, correct?
Yes, sir.
Yes, sir.
Right. So that same layout in word processing in your final term in fourth form, you will have to design a letter also. And for those who do in EDPM, they have to design letters also. So that skill or that knowledge that you would have learned as to how to design a letter, where to put the address, where to put the body, where to put the salutation, and how to format everything, you have to apply those skills inside of that word processor to create your letter. So not everything is basically just learning about knowledge for a certain topic. You actually have to use it in other areas of learning. So formulas, they follow BODMAS, and we all should know what are the rules of BODMAS. The brackets, then order, division, multiplication, addition, and then subtraction. So moving on, as mentioned, your formula is a mathematical equation. That's why it follows BODMAS. So when you're creating your formula, it can use actual values. So actual values are going to be numbers, like you saw me creating a formula here with actual values. It can use cell addresses, as mentioned already, and it can use a combination of both cell address and a value. So nothing's wrong with using a value, but in some cases using a cell address is going to be more effective, and we already looked at why cell addresses are more effective. Anybody remembers why? There's a main reason why cell addresses are more effective. They allow us to do what? It's two words. First word starts with A.
Sir, automatic calculations.
Right. Automatic calculations. If you use actual values, you won't get automatic calculations because you have to manually change the values. But cell addresses, they give us that benefit of automatic calculations. So that's why it's more effective. But once again, nothing is wrong with using actual values. There will be situations where you will have to use a value. So that's why we can use it by itself or just cell addresses or a combination of the two. So when we're creating a formula, always remember that we start with an equal sign. If we do not put an equal sign, it will not register as a formula and it will not work. Alright, so any questions so far?
No, sir.
Alright, so we're getting on to the part now where we're going to be looking at quite a few functions, and you guys are going to have to take note of basically what is the structure of the function. Each function has a different structure. So remember, functions are basically what? They're basically what?
So they're built-in calculations that help you. It's like built-in into the system.
Right, a built-in calculation, a built-in equation, a built-in formula, however you want to say it, however you want to think about it, is going to do some sort of calculation. And unlike a formula where you can say 6 plus 6 minus 3, for the function you cannot type in operators, you cannot say do this, do that. So you have to understand what is the structure of the function in order to make it work. Some of them are simple, but some of them are a bit more complicated. For example, look at this one here. This one has 3 parts. This one has a test, this one has a true value, this one has a false value. And the one that's going to give you guys the most headache is this one here. So when it comes to functions, it's not about learning about formulas, equations and the rules of equations. It's about learning the structure of a function. Each function has a structure. So let's look at firstly what is a function, and then we'll look at some examples of functions. So Ramona, can you start the reading for us?
Functions. Functions are a powerful part of Excel. The syntax or structure of a function is the equal sign, the function name, an open bracket, one or more arguments for most functions, and a close bracket. Function name or more arguments. An argument is mostly a cell reference, a range of cells, or a constant number. There are some functions that do not use arguments, but you still need the open and close brackets. The number of arguments will vary in different functions. The following examples illustrate some frequently used functions.
Great. So here we have the structure, the general structure of a function. It always starts with an equal sign, just like a formula. The name of the function is always going to come after the equal sign, and then you're going to always open a bracket after the name of the function. Inside of the bracket, you put arguments based on the structure. Some require 1 argument, 2 argument, 3 argument, 4 argument. Some require no argument. So depending on the structure, that's how many arguments you put inside the bracket, and then you close the bracket. So the bottom here, this is the general structure: equal sign, function name, open bracket, you put the arguments inside of the bracket, and then you close the bracket. That is the general structure. Now, what is the argument? The argument is basically a cell reference, A1, A2, A3, whatever the cell is, or it could be a range of cells, A1 to A5, B1 to B5, or it could be a constant number, maybe 5, 10, 100. Those are your arguments. It's basically what you want to calculate. It could be a cell reference with the value inside the cell, or it could be that constant number if you don't want to use the cell reference. Now, as mentioned, not all functions require a argument, but they still require that open and close brackets. So it's still the same structure, equal function name brackets, but it's either no argument or you have to put in one or more arguments. So it should be either no or one or more arguments. That is the general structure. But it's only a limited amount of them that would have no arguments. So let's look at an example to give us an idea of the structure of a function. So the first function we're going to look at is the average function. Ray Mario, can you read for us? Ray Mario? Roshana?
Sir, could I read?
Go ahead.
The average function calculates the average of a range of cells. The syntax is average in brackets plus range of cells. As an example, if you were to enter into cell B3, B4, B5, B6, and B7, how much money you spend on lunch each day of the week, this function can be used to calculate your average daily spending.
Great. So our first function is the average function, which is used, as the name indicates, to calculate the average based on a range of cells or a range of values, whatever the case may be. Now, whenever you are basically calling out a formula or a function, I want you guys to start developing the habit of saying the brackets. It's important for you to start saying the bracket. So equal average open bracket, range of cells A1 to A5, close bracket. That will help you to memorize that you need to make use of brackets. And remember, brackets are a part of the syntax, so you cannot just leave them out when you're describing them. So let's look at average, an example of using average. If I can spell average. So let's put in some values. Well, it should bring it down. And then fill. Good. So we're going to use average on that. So equal sign, the name of the function. So anybody remember what was the two methods that we can use to automatically fill out the name? I would have mentioned that in one of the earlier classes. Instead of typing out the rest, we have two shortcuts that we can use to automatically complete the name.
So I think you could like select from 1 to 5 and it would insert in the bracket by itself.
Yeah, that's for automatically putting in the range, but I'm talking about completing the name of the function. There's two shortcuts that we can use instead of typing it out.
So you see the thing that the cursor is on currently, you tap on that.
Good.
Yeah, that's a shortcut. Yeah.
So it's not just tapping on it, you have to double click on it, and that will automatically complete the name of the function plus open the bracket for you, so you don't have to type the bracket. And there's another method double clicking on it, and it's a key on the keyboard that you would press. That is going to be the tab key. So if you use the tab key, it will complete the function and add the bracket based on basically what is highlighted. So if you notice, this first one here is highlighted. So if I press tab, that is what will appear. So it's just basically a faster method of completing the function and adding your bracket. So average open bracket, and we put in our range of cells, and we close our bracket, and we have our calculation there. So it's that simple. We could also put in numbers. So if we want to do 4, 3, 6, I notice comma is used to separate the numbers, and we have our calculation there. So we can use actual values, or we can use the cell ranges, either one. But we know how ineffective using actual values are, because whenever we want to change a value, we have to go into the formula and make that change, which is going to be a little more tedious. So using the cell range is always going to be more effective, so that whenever a value changes, it will automatically recalculate. Great. So you guys following on the average function?
Yes, sir.
Alright, so next we're going to look at count A and count. So please do not pronounce this as counter. It's count A. So our next reader is going to be Ritisha.
Count A and count. The syntax is equal count A, open bracket, range of cells, and equal count, open bracket, range of cells. These functions count the number of cells in a range. Notice that count counts the numbers in a range, while count A counts numbers but also other data, such as text or non-blank cells in the range. Suppose you and some members of your class volunteer to collect money for charity. You enter the contributions collected into cells C1 to C4. Then you can use the count function to count the number of contributions received. There is also the count A function, which counts the number of cells in a range that are not blank or may contain text.
Good. So we have two additional functions here. We have the count and the count A. Now count is used to count numbers. We actually have 3 different counts that you guys have to learn basically. So they all are used to count some sort of data, count different forms of data. Count is used to count numbers. Count A is used to basically count any other data, such as text or non-blank cells. So the A, what can help you to remember is that the A represents letters. Count does not count letters. It does not count text. It only counts numbers. So the A should help you to remember that it is counting any other data. It is counting numbers and text. So let's see how they work. I notice the structure, it is similar. It's a simple structure, just like average. It's only asking for the range of the cells. So if we were to, let's put back 1 there. We're going to use count to the bottom here. We are going to count how many cells we have here. So it's going to be equal count, open brackets, we highlight our range, and it counted 5 cells of data. So if we remove one, we now have 4. Remove another one, 3, another one, 2, another one, 1, and now we have no data in that range. So notice it's only counting numbers, and it's only counting if the cell has a value. If there's no value, obviously it would not be counted. So if you put in text now, notice it changed to 4. More text, 3, more, 2, 1, 0. We now have no numbers. So count only counts numbers. What about count A? So count A, open brackets, this is going to be count A, equal, open bracket, count A, equal count A, open bracket, the range, and then we have our answer here. So notice it's the same 5. Now if we replace 2 with the word red, notice only count changed. So let me put them in some different colors. Good. So notice only count change. I'm going to put back the number. Count change back because count only counts numbers. If I delete the data from one of the cell, notice both drop to 4 because it does not count blank cells. It must have data inside of it. It must either have a number or text inside of them. So only count A would count both numbers and text, whereas count would only count numbers. So depending on the situation, if you want to count maybe how many prices you have, if you have a list of age, how many age is listed there, you can use count. But when you have text, then you would use count A. Alright, are you guys following?
Yes, sir.
Yes, sir.
Yes, sir.
Any questions so far?
No, sir.
Alright, I think that is it from count and count A. Good. So please remember what is the difference between the two and what does it count. Now we're going to look at the other count, count if, and the syntax for count if is equal range of cells, and notice we have another argument. We have 2 arguments. We have a range of cells and we have the criteria argument. So this function counts the number of cells that meet the criteria. I want you guys to take note of something. This word criteria. Does anybody know what criteria means? Or can somebody look at the definition and tell us what is criteria?
Sir, it says a principle or standard by which something may be judged or decided. So basically, I would say conditions by which you have to follow or something like that.
Good. So criteria is some form of condition, some form of standard, something that you're going to be guided by, some rule that you must follow. So throughout IT, you're going to be hearing about this term criteria. Spreadsheet, you're going to be hearing it about a lot. There's other functions that use criteria. In database, you're going to hear about criteria. In programming, you're going to hear about criteria. Whenever you hear this word criteria, think of some sort of condition. Think of some sort of rule that must be either true or false for something to happen, for something to take place. And in most cases, it's going to be some form of calculation or something of that sort. So whenever in IT you see criteria, at the most basic level, you should always be thinking of these signs. Anybody know what are these two signs here? Let me draw it a little better just in case.
More than, less than, and equal.
More than, less than, and equal. Good. So these signs here are basically what you are going to be using a majority of your time for your criteria. So whenever you hear criteria, think of these signs here. Think of, is something less than something? Is 3 less than 10? Is 3 greater than 10? Is 3 equal to 10? Always think of those three signs. Is something less than? Is something greater than? Is something equal to? Those are going to be your criteria a majority of the time. That's basically what you're going to be asking all the time. So whenever you think of criteria, I want you to think of the word question. What is the question you are asking? The question is usually going to be, is something less than something? Is something greater than something? Or is something equal to something? Or it can also be another one. There's a fourth one that relates to equal. What's that one? What is this here? No one? Y'all never saw the symbol before?
Yeah, I don't remember it off the top of my head.
This is the
Or is it equivalent?
It's a not equal to. So this is not equal to. So you're not gonna, I don't think you're gonna use it that often as criteria, but as mentioned, criteria is basically like asking questions, and these are the most common ones that you're gonna be using. If something is less than, if something is greater than, if something is equal to. I think it's only a few cases it makes use of the not equal to, but just focus on the first three. So whenever you hear criteria, think of question. Now the count if, the structure is a range of cells and a criteria. So the function count if is used to count how many classmates donated less than $10. Notice that only 2 students donated less than $10 because the function did not include the option donating exactly 10. So let's look at an example. So let me put back 2 there. We're going to look at count if. So equal count if, and the first criteria or the first argument, if you look at the bottom here, notice it always gives you a hint as to what are the arguments. So notice the first part here, you can click on it because it's highlighted also because you're in that part of the formula. You're in that part of the function. When you put the comma, notice you moved over to the other part. Notice this one here is highlighted. So it tells you what part of the function you are working on. So let's go back before the comma. We're going to highlight our range. So that there's our range, comma. What is our criteria? Give me a second. This thing, highlight that, delete that, go back. Good. So what is our criteria now? So now we can ask, is something, let me zoom out a bit, equal count if our range. So now we can be asking, is it less than, is there any value less than 3? Remember, this count if is for counting, so it's still functioning the same way. It is counting the values, but we're giving it a criteria. It's going to count, but it's going to only count if the values are less than 3. Now if we do not put quotation marks, we will get this error here. So we need to put in our double quotation marks, and we will get our complete function. So equal sign, name of the function, open brackets, the range, and our criteria in double quotation marks. So the criteria is, in this range here, is there any value less than 3? We have 2 and we have 1. So it counted 2 values less than 3. If you change it 3 to 5, how many values do we have less than 5? We have 4 values. We have 1, 2, 3, 4. So if we wanted all the values, we would need to put less than 6, because less than, anything that you use with less than, it does not give you the exact value. It does not give you that equal value. You guys should know that from how less than and more than works. I think it's less than equal to, yes, I don't see less than equal to 5. Yes. So in your criteria, this is another symbol that you will basically another question that you'll be using. So in addition to less than and less and more than, you're going to be using less than equal to and more than equal to. Let me see how the other sign is going to be. So less than, equal to, and more than. Yeah, so that's going to be more than, equal to. So these are the most common criteria, the most common questions that you're going to be asking yourself when you ever come across criteria. Is something less than? Is something greater than? Is something equal to? Is it less than equal to? Or is it greater than equal to? And when it answers that question, when it looks at that criteria, it counts the range and give you back your value. Are you guys following? Or was that a bit too technical?
Sir, for good measure, please go once more, please.
Alright, so just like our count function, it's basically an addition to our count function. Count, we understand how count works, right? Everybody at that page? Is everyone there? We understand how count
Yes,
works.
sir.
So count, and we have the range. It looks at that range and it counts the values. That's all count does. It looks at the range and counts the values. It has basically no prejudice. It doesn't matter what is inside of that range, it counts. Now count if is basically, it's looking for some form of range. It's looking for some form of criteria you can say it has some form of prejudice. It only wants a certain specific category, a certain specific value. So it's the same count, it's counting, but if it is within this range, if it is within this criteria, if it answers this question. So it's going to look at the range. It always has to have a range of data, and then it's going to have a question. So the criteria is going to be a question. Is there any value less than 5? So this criteria could be anything. Is it less than 100? So if there is any cells, remember it's counting the cells. If there's any cells with values less than 100, it is going to count those cells. So yes, all of these values here are less than 100, so they were all counted. If we drop it now to 4, it's asking now, so basically we need to look at the criteria first. It's asking, is there any value less than 3? The values less than 3 are going to be 3, 2, and 1. It's going to be these values here. So we have 3 cells that has a value less than 4. So when it counts that range, when it looks at that range, it's going to see only 3 values less than 4, and that is why we have 3 as our answer here. So it's always going to look at this criteria first. It's going to compare that criteria to the range, and based on the criteria, it's going to count the cells. Is that helping, or is it still confusing?
That's better, sir.
Anyone still confused? Please remember, you have to know how all of these functions work, how they are structured, how they operate. So if you do not understand now, please don't wait later on when we start getting into more complicated functions, because this is still a relatively simple function compared to the rest. Alright, so I'm not hearing any questions. So in review of what we looked at today we looked at some questions that you should ask yourself whenever you're designing a spreadsheet. What is the goal? What is the results? What data you need to put in? What calculations you need to carry out whenever you're designing a spreadsheet? When it comes to formulas, it always follows the rule of BODMAS. So take that into consideration whenever you're creating a formula. Not all formulas, not all situations you're going to be able to use a function. There are some cases where you will need to create your own formula, because there's not a function for every form of calculation. So you need to understand how formulas are created using that BODMAS system so that you can effectively create a formula. And then we started looking at what is a function, what is the basic structure of a function, and we looked at average, count, count A, and count if. Please remember to practice on these. You have Google Sheets. If you do not have Microsoft Excel, use Google Sheets. Your phone can have access to Google Sheets so that you can practice using these functions. Alright, if you guys don't have any questions, we're going to end here for today. Enjoy the rest of your day.